Welcome to the Deep Dive. Today we're tackling a really significant global health issue, malaria.
Indeed. It affects millions.
We've got a comprehensive collection of information here, and our mission, really, is to cut through it all, pull out the most vital knowledge.
Get to the core of it.
Exactly. We want to understand what malaria fundamentally is, how it works, its impact, and importantly, what's being done about it.
Clarity over clutter.
That's the goal. So let's dive right in. First question, what exactly is malaria? It's not a virus, right? But bacteria.
No, that's a really key distinction to make up front. Malaria is a parasitic disease.
Parasitic, okay.
Yeah, the culprits are these microscopic parasites. They belong to the Plasmodium genus.
Plasmodium, got it.
These tiny things, they invade the human body. And it's their life cycle inside us that causes all the trouble.
It's kind of wild that something so small can cause such huge problems globally.
It really is quite staggering when you think about the scale.
Okay, so these Plasmodium parasites, how do they actually get around from person to person? This is where the mosquitoes come in.
Precisely. That's the vector. Malaria is transmitted through the bite of infected female Anopheles mosquitoes.
Females specifically. Why only female?
Good question. It's because only the females bite and feed on blood. They need it for their eggs. The males, they just feed on plant nectar.
Interesting detail.
And these female mosquitoes, they typically bite at night, mostly dusk till dawn.
Which has implications for prevention, I imagine, like bed nets.
Absolutely. Bed nets are effective precisely because of that nighttime biting habit.
And you mentioned Plasmodium parasites. Is it just one type we're talking about?
No, actually, there are several. Our sources identify 5 species that infect humans.
5, okay.
Yes. Falciparum, vivax, Malaria, ovale, and knowlesi.
Wow, okay. Are they all equally bad?
Not quite. While they all cause illness, Plasmodium falciparum is by far the most dangerous.
Falciparum. Why is that one so much worse?
It's responsible for the vast majority of malaria deaths worldwide, mainly because it multiplies incredibly quickly in the bloodstream, and it's the one most likely to lead to severe, life-threatening complications.
Okay, falciparum is the big one to watch out for. What about the others? I think I read something about P. vivax causing relapses.
Yes, that's right. P. vivax is, well, quite interesting in a concerning way. It can cause relapses.
How does that work? A relapse?
It has this dormant stage in the liver. They're called hypnozoites.
Hypnozoites. Like sleeping parasites.
Sort of, yeah.
Well,
So someone gets treated, feels better, the parasites in the blood are gone, but these dormant ones can just wake up weeks, months, even years later.
without another mosquito bite.
Exactly. They reactivate and cause another bout of malaria, makes getting rid of Vivax in certain regions much trickier.
Right, because you need treatment that hits those liver stages too.
Precisely. Often requires specific drugs like primaquine, adding complexity.
So let's trace that transmission again. An infected person gets bitten by a female Anopheles. What happens next? Inside the mosquito.
Okay, so the mosquito takes a blood meal, ingesting the Plasmodium parasites along with the blood.
Right.
Inside the mosquito's gut, the parasite then has to undergo this crucial development period. It needs to mature.
How long does that take?
Typically around 10 to 14 days. It depends a bit on things like the ambient temperature.
Okay.
Only after that maturation period can the mosquito actually transmit the parasite to another person when it bites again.
So there's a lag time in the mosquito itself.
Yeah, it's a necessary step in the cycle. It's a 2-host life cycle, human to mosquito, development in the mosquito, then back to human.
Makes sense. Now, looking globally, malaria isn't everywhere. Why are some places hit so much harder? What makes a region susceptible?
You're right, it's very geographically focused. The prevalence is heavily tied to climate and environment.
How so?
Well, the Anopheles mosquitoes, they need certain conditions to thrive. Warm, humid climates are ideal. And critically, they need stagnant water for breeding. Puddles, ponds, marshes, even water collected in containers.
So tropical and subtropical regions mostly.
Exactly. That's why the most affected areas are places like sub-Saharan Africa, which bears the brunt of it, but also South and Southeast Asia, parts of South America, the Caribbean, and some areas in Oceania.
And within those regions, is the risk constant, like all year round?
Not always. In some places with very stable, warm, wet conditions, yes, transmission can happen year-round.
Okay.
But in many other areas, it's seasonal. It follows the rains, basically.
Ah, because more rain means more stagnant water, more breeding sites.
You got it. Rainfall and temperature patterns directly impact the mosquito populations. Understanding that seasonality is key for timing interventions, like spraying or distributing nets.
Right, makes sense. Okay, so the infected mosquito finds its next victim, bites them. How long until that person actually starts feeling sick?
The incubation period typically is around 10 to 15 days after the bite.
2 weeks, roughly.
Yeah, about that. But the tricky part is the initial symptoms are often very nonspecific.
Like,
Fever, chills, headache, muscle aches, maybe feeling really tired, very flu-like.
so it could easily be mistaken for something else, especially at first.
Exactly. Especially in places where malaria isn't common, doctors might not immediately suspect it. That can delay diagnosis and treatment.
But then things can escalate, right? You get those classic malaria symptoms, the cycles.
Yes, that's the hallmark for many people. These recurring episodes, cycles of high fever, intense chills where you're shaking uncontrollably, then profuse sweating.
What's actually causing that cycle inside the body?
It's directly linked to the parasite's life cycle in the red blood cells. The parasites multiply inside the red cells, and then large numbers of these infected cells burst open pretty much simultaneously.
Wow.
That releases a flood of new parasites into the bloodstream to infect more cells, and it also triggers that intense immune reaction, the fever and chills.
That sounds absolutely brutal. Are there other common symptoms besides the fever and chills?
Yes, definitely. People can experience nausea, vomiting, diarrhea, abdominal pain. These are particularly common in children.
So quite a range of symptoms then.
It can be, which again sometimes makes diagnosis a bit tricky just based on symptoms alone, and the real danger is if it's not treated promptly.
Let's talk about that. What happens if malaria goes untreated? What are the severe complications?
Well, especially with P. falciparum, untreated malaria can quickly become severe and life-threatening. We're talking about serious complications.
Oh, such as?
Severe anemia is a big one from all those destroyed red blood cells, hypoglycemia, dangerously low blood sugar, jaundice because the liver gets overwhelmed dealing with the breakdown products,
Okay.
and it can lead to organ failure, kidney failure, respiratory distress. It can affect multiple systems.
And I've heard of cerebral malaria. That sounds terrifying. What is that?
It is. Cerebral malaria is almost always caused by P. falciparum. It's one of the deadliest complications.
What happened?
Essentially, the infected red blood cells become sticky. They adhere to the walls of the small blood vessels in the brain.
Oh, wow. Blocking blood flow.
Exactly. It causes blockages, inflammation, swelling in the brain. This leads to neurological symptoms, seizures, confusion, loss of consciousness, coma, and sadly, it's often fatal, particularly in young children.
It just underscores how dangerous falciparum can be.
Absolutely.
The sources also really emphasize the risk for pregnant women and young kids. Why are they so much more vulnerable?
Yeah, these groups face significantly higher risks. Pregnant women are more susceptible to getting infected in the first place, and the infection can cause serious problems for both mother and baby.
It's like,
Miscarriage, stillbirth, premature delivery, and low birth weight babies. Low birth weight itself carries long-term risks for the child's health.
and for young children.
Young children, especially under 5, are incredibly vulnerable because their immune systems haven't fully developed yet.
So they can't fight it off as well.
Right, they haven't built up any immunity through prior exposure. So when they get infected, the parasite can multiply rapidly, and they're much more likely to develop severe malaria and die. That's why the vast majority of malaria deaths occur in this age group.
That's tragic. Now, what about people who live in areas where malaria is, common, endemic?
Yeah.
They get infected repeatedly. Does that offer any kind of protection over time?
Yes, it does. It's a really important concept called partial immunity.
Partial immunity.
Yeah. People who are exposed to malaria repeatedly, especially from a young age, their immune systems gradually learn to control the parasite better.
So they don't get as sick.
Often, yes. It doesn't usually prevent infection altogether, but it means subsequent infections are less likely to cause severe disease or death. They might still get mild symptoms, feel unwell.
But it's not complete immunity. They can still get malaria and pass it on.
Correct. They can still get sick,
Yeah.
and they remain part of the transmission cycle. And it's crucial to remember this partial immunity develops over years of exposure. Someone from a non-malaria area, like a traveler, has zero immunity.
So even one infection could be really serious for them.
Potentially fatal, yes, because their body has no defense mechanism built up.
Okay, so someone shows up with symptoms, fever, chills. How do doctors actually confirm it's malaria? What are the diagnostic tools?
The gold standard, the most reliable method, is looking at the blood under a microscope.
Microscopy.
Yes. You take a drop of the patient's blood, smear it on a glass slide, stain it with special dyes, and then a trained technician looks for the actual malaria parasites inside the red blood cells.
Can they tell which species it is that way?
Yes, a skilled microscopist can usually identify the Plasmodium species, which is important for treatment decisions, and they can also estimate how many parasites there are, the parasite density.
Okay. But microscopy requires labs, trained staff. What about areas without those resources? I know rapid tests are used a lot.
Exactly. Rapid diagnostic tests, or RDTs, have been a game changer, especially in low-resource settings.
How do they work?
They're kind of like a pregnancy test in principle. They detect specific proteins, antigens that are produced by the malaria parasites circulating in the blood.
And they're fast.
Vary. Usually results within 15 to 20 minutes. They don't need electricity or complex equipment, just a drop of blood.
So you can get a diagnosis and start treatment much quicker.
Precisely. Which is critical for improving outcomes, especially in remote areas. They're incredibly valuable tools.
Right. So once malaria is confirmed, either by microscope or RDT, treatment needs to start immediately. What does that usually involve?
Yes, prompt treatment with effective antimalarial drugs is absolutely key. The specific drug choice depends on a few things.
Like what?
Well, first, which Plasmodium species is causing the infection? Second, where did the person likely get infected? Because drug resistance patterns vary geographically.
Oh, right. A drug that works in one place might not work somewhere else.
Exactly. And third, how severe is the illness? Is it uncomplicated malaria or severe malaria?
Makes sense. The information mentions ACT's artemisinin-based combination therapy as being really important, especially for that dangerous P. falciparum. What's special about ACTs?
ACTs are currently the frontline treatment for uncomplicated P. falciparum malaria pretty much everywhere. They're highly effective.
Why combination therapy?
That's the key. They combine two or more drugs with different ways of attacking the parasite. One component is always an artemisinin derivative. These act very quickly to knock down the number of parasites,
Okay.
and the partner drug works differently and lasts longer in the body, helping to clear the remaining parasites. This combination approach makes it much harder for the parasite to develop resistance.
Smart. Reduces the chance of treatment failure and slows down resistance.
That's the idea. It's been a major factor in reducing malaria deaths.
Are other drugs still used besides ACTs?
Oh, yes, depending on the situation. For example, chloroquine might still be used for PVVAX in areas where it's still sensitive.
Right.
And drugs like primaquine are essential, as we mentioned, to clear those dormant liver stages of VVAX and OVAL to prevent relapse. Then there are others like quinine, mefloquine, atovaquone-proguanil. The choice depends on the specifics.
And regardless of the drug, I assume it's vital to finish the whole course of treatment.
Absolutely critical. Even if you start feeling better after a day or two, you have to complete the full prescription.
Why is that so important?
To make sure all the parasites are eliminated, including any slower-acting ones, stopping early increases the risk of the infection coming back, potentially stronger, and it really fuels the development of drug resistance.
Got it. Finish the pills. What about people who develop severe malaria? Hospitalization needed.
Definitely. Severe malaria is a medical emergency. It requires urgent hospitalization.
And the treatment is different.
Yes, it's more intensive. Usually involves giving antimalarial drugs intravenously, like IV artesunate or quinine, to get high drug levels into the system quickly and kill the parasites fast.
Okay.
Plus, crucial supportive care is needed to manage all those complications we talked about, treating anemia, low blood sugar, supporting kidney and lung function. It's intensive care, really. And special care protocols for pregnant women and young kids with severe malaria.
Okay, so treatment is vital. But obviously, preventing people from getting malaria in the first place is even better. What are the main prevention strategies?
Prevention is absolutely central, and a lot of it focuses on the mosquito vector, reducing human-mosquito contact.
How do we do that? Bed nets.
Insecticide-treated nets, ITNs, yes, they're a cornerstone. Basically, bed nets treated with a safe, long-lasting insecticide.
Simple but effective.
Remarkably effective. Sleeping under one at night provides a physical barrier against biting mosquitoes, and the insecticide kills or repels any that land on the net. Huge impact, relatively low cost.
What about spraying? I hear about IRS.
Right, IRS indoor residual spraying. That involves spraying the inside walls and ceilings of houses with a long-lasting insecticide.
How does that help?
Mosquitoes often rest on indoor walls after they've fed. If those walls are treated, the mosquito picks up a lethal dose of insecticide and dies before it can bite someone else.
So it shortens the mosquito's lifespan and reduces transmission.
Exactly. It can be very effective, especially when applied systematically across a whole community.
And what can individuals do? Personal protection.
Yes, simple measures help. Wearing long sleeves and trousers, especially in the evenings and early mornings when anopheles are most active, reduces exposed skin.
Makes sense.
And using insect repellents on exposed skin, ones containing effective ingredients like DET, picaridin, or oil of lemon eucalyptus.
Okay. What about travelers going to malaria zones? They're often told to take medication before they even go.
Correct. That's called chemoprophylaxis, taking preventive anti-malarial drugs.
Prophylaxis, right?
Yeah. Drugs like doxycycline, ibuprofen perguanil, or mefloquine are common options. You start taking them before you travel, continue during your trip, and for a period after you return.
Why after?
To catch any parasites that might have entered the bloodstream towards the end of the trip and are still intubating, it's really important for travelers to talk to a doctor or travel clinic well before their trip to get the right advice and prescription for their specific destination.
Absolutely. And adherence is key there too, I bet.
Definitely. You have to take it exactly as prescribed.
What about tackling the mosquitoes where they breed? Getting rid of stagnant water.
Yes, environmental management. It's a crucial piece, maybe sometimes overlooked. It means reducing or eliminating the places where mosquitoes lay their eggs.
So practical things like
Simple stuff, often. Draining standing water from containers around homes, flower pots, old tires, buckets, cleaning gutters, covering water storage tanks, improving drainage and waste management in communities.
requires community involvement, I guess.
Hugely. Education and community participation are vital for making environmental management work long-term.
Now, moving on to something really exciting, the vaccine. This feels like a huge step forward, doesn't it?
It really is a major breakthrough after decades of research. The RTS vaccine, brand name Mosquirix.
Mosquirix, that's the first approved one.
Yes, the first and currently the only one approved by the WHO. It's been piloted in Ghana, Kenya, and Malawi.
And how's it going? What are the results like?
The results from the pilots have been very positive. It's shown a significant reduction in malaria cases and, importantly, in severe, life-threatening malaria among young children who received the vaccine doses.
That's fantastic news.
Yeah.
But it's not like 100% effective, is it? It doesn't completely stop malaria.
No, that's an important point. It doesn't offer complete protection, and the immunity it provides does decrease over time.
So how is it best used then?
It's seen as an additional tool, a very valuable one, to be used alongside existing interventions.
Like nets and prompt treatment.
Exactly. When used together with ITNs, spraying or appropriate good diagnostics and treatment, it adds another layer of protection and significantly boosts the overall impact, especially for those most vulnerable young children.
So it's being rolled out more widely now.
Yes. The recommendation is for it to be used in areas with moderate to high transmission, integrated into routine childhood immunization programs. And research is definitely continuing, pushing for next-generation vaccines that might be even more effective or offer longer-lasting protection.
That's encouraging.
Huh.
So let's step back again, the bigger picture. Where do we stand globally with malaria today? Still a massive problem.
Oh, absolutely. Despite all the progress, it remains a major global health challenge, especially affecting low-income countries.
Do we have recent numbers?
The WHO estimated for 2022 something like 249 million malaria cases worldwide.
249 million cases, wow. And deaths.
Over 600,000 deaths in that year. And the heartbreaking part is the vast majority of those deaths, around 80%, are still in children under 5 in sub-Saharan Africa.
Still an immense burden.
Immense. Affecting health, obviously, but also economies, education. It's a huge barrier to development.
But as you said, there has been progress over, say, the last 20 years or so.
Yes, definitely. Significant progress has been made since around the year 2000. Cases and deaths have fallen substantially in many parts of the world.
What drove that progress?
A combination of things. Greatly increased international funding was key. That allowed for the massive scale-up of those core interventions we've discussed. The ITNs, the spraying, better diagnostics like RDTs, and the widespread use of effective ACT treatments.
So a concerted global effort really paid off.
It really did. Collaboration between governments, international agencies, researchers, NGOs, communities, it showed what can be achieved.
So looking forward, is a malaria-free world actually, achievable? Is it a realistic goal?
It's definitely the ultimate goal. And I think it is achievable, yes, but it's ambitious, and it won't be easy or quick.
What's needed to get there?
Sustained political will is crucial. Continued and likely increased funding, and constant innovation.
Innovation in what areas?
across the board. Better diagnostics, new drugs to combat resistance, next-generation vaccines, potentially new tools for mosquito control like gene drives, and strengthening health systems overall so these tools can actually reach everyone who needs them.
So challenges remain, but there's a path forward.
I think so. There's an optimistic outlook, grounded in realism about the challenges, but the science is advancing, and the global commitment seems strong. Continued cooperation is absolutely essential.
Okay, let's try and wrap this up. We've covered a lot of ground on malaria.
They certainly have.
So the key things to take away: it's parasitic, spread by specific female mosquitoes, causes symptoms that can range from flu-like to deadly, especially cerebral malaria and severe anemia.
Right, and it disproportionately affects young children and pregnant women.
But there's this multi-pronged attack against it. Prevention through nets, spraying, repellents, prompt diagnosis with microscopy or RDTs,
Yeah.
effective treatments like ACTs, and now, excitingly, the first vaccines rolling out.
Exactly. It's a complex biological and public health issue, deeply intertwined with environment and poverty.
It really highlights how malaria isn't just a disease, it has these huge ripple effects on societies and economies.
Profound impacts, absolutely, hindering progress in so many ways.
So here's something to leave you, our listener, thinking about. Given the incredible progress we've seen, especially with tools like ACTs and the new vaccine, what do you think are the biggest hurdles still standing in the way of a malaria-free world? Is it drug resistance, funding gaps, reaching remote populations, climate change impacting mosquito ranges, and maybe more importantly, how critical is continued, maybe even strengthened, global collaboration and investment to overcome those final hurdles? It really feels like we're at a pivotal point.
A lot to consider there. The fight is far from over, but the goal is in sight.
Thanks for taking this deep dive with us today.